battlefields of the future will be more dangerous than ever. In the 21st century, there will be threats to our freedom and security like never before. But will we be ready? Battles will be fought on land and sea, but they will not be won without supremacy in the air. Enter the incredible world of 21st century combat.
Air power is the dominant strategic force. It's air power that lets you influence events and respond to events quickly. It's air power that lets you fight a war without putting hundreds of thousands of people on the ground.
To date, Air Force F-15s have won more than 150 dogfights against enemy fighters without a single loss. And the Navy F-18 Hornet is widely recognized as the world's best carrier-based fighter bomber. But in the future, neither the F-15 nor the F-18 will be able to survive against deadly enemy anti-aircraft missiles.
Surface-to-air missiles, or SAMs, are going to represent the biggest threat. Those very formidable systems developed in Russia or China will have to be taken out of action very quickly in any future conflict.
The fighter of the future will need to be stealthy to slip past enemy radar. It must be able to take out anti-aircraft installations. And it must out-dogfight any enemy fighters that get in the way. That future fighter is already here. The F-22 Raptor, the air dominance fighter of the 21st century. Developed by Lockheed Martin, this advanced tactical fighter has been designed to be the first plane to cross enemy lines, clearing the way for all other forces.
The F-22 is both an air-to-air fighter and an air-to-surface fighter, so it can drop precision weapons.
That means it'll be able to go in early in a conflict, knock out all the air defenses that an enemy has, and also take out certain ground targets. And open the door for all the U.S. forces, whether they're ground vehicles or other aircraft, to come in and continue the fight.
The development of the F-22 Raptor first began in 1985, when the Air Force requested proposals for an advanced tactical fighter jet to replace the F-15 air superiority fighter. Military planners feared that the F-15 would not be able to counter new air and ground threats on the horizon. The result was the creation of the F-22.
The capability of the aircraft is a quantum leap above what exists right now, and it's going to take air power and revolutionize it into a whole new world.
In the battles of the future, stealth will be critical for all new fighters to avoid being seen by enemy radar.
Non-stealthy aircraft just will not survive in the air battles of tomorrow.
Stealth technology was created to counter advances in radar. Radar works by sending out radio waves and measuring the amount reflected back to determine the distance, speed, and course of an object. But stealth aircraft are designed with surfaces that deflect radio waves away, making them nearly invisible to radar. The world's first stealth production aircraft was the F-117 Nighthawk.
The reason that airplane is faceted is a limitation of the computer technology at the time. It's easier to model a finite number of flat surfaces than it is a bunch of curved surfaces.
And while the aircraft was a breakthrough at the time, the facets limited the plane aerodynamically. But now, thanks to more powerful computers, engineers can design aircraft that do not have to sacrifice aerodynamics for stealth.
The FA-22's aerodynamic slickness allows it to have the lowest drag of almost any aircraft ever produced.
The F-22's aerodynamic superiority, combined with its stealth and firepower, make it a far better adversary than any aircraft before it. The F-15, which the F-22 will replace, has been a very successful fighter, but it is not stealthy. The F-117, while stealthy, carries no air-to-air weapons and is not designed for air combat. It relies on stealth and mission planning to protect itself. But the F-22, on the other hand, is not only stealthy, but comes with a full complement of air-to-air and air-to-ground weapons.
The primary armament is in weapons bays underneath the airplane, where we carry 6 medium-range radar-guided missiles.
By carrying the weapons internally, it preserves the stealthy shape of the plane. For closer infighting, the F-22 has short-range missiles and guns.
Behind these two doors right here is the side weapons bay. This is where we carry a heat-seeking missile. For close-in armament, the Raptor is equipped with the M61A2 cannon. The muzzle is hidden right behind this door right here. It's hidden because of the stealth characteristics of the airplane. Cannon carries 480 rounds and is capable of shooting 100 rounds a second.
The F-22's advanced weapons systems will make it a formidable interceptor, as will its unique ability to find enemy aircraft without revealing its own position. When other planes use their radar, they become visible to every other radar system in the area. But that's not the case with the F-22.
Perhaps the highest tech part of the airplane is the radome itself. Not only does the radome have to be stealthy, but it has to be able to transmit and receive its own radar signals.
How the F-22 radar achieves that remarkable feat is classified. But what is known is that the F-22 can see enemy aircraft at a distance while remaining invisible to them.
The first time that the bad guys will really know there's an F-22 in the area is when one of them blows up.
Along with its advanced radar system, the F-22 is the first fighter to have supercruise, the ability to travel faster than the speed of sound without using its afterburners. A jet's afterburners boost speed by pouring fuel directly into the hot blast of the engines, adding fiery extra thrust. But afterburners are also wasteful, consuming enormous amounts of fuel, dramatically affecting the range and duration of a plane's mission. But the F-22 doesn't have that problem. Without using afterburners, it can supercruise at an incredible 1.5 times the speed of sound, over 1,000 miles per hour.
This is all about our pilots being able to go fast, minimize the amount of time they are exposed to any threat, do the mission that we've sent them to do, turn around and come home safely.
The F-22 is presently the only fighter in the world with supercruise, but it wouldn't be possible without a very unique set of engines.
The goals for Pratt & Whitney were to provide a transformational engine that the Air Force needed, one that was stealthy, maintainable, and fast.
The F-119 PW100 was developed by Pratt & Whitney after years of research. It sets the new standard for jet engines. Along with its incredible supersonic ability, the F-119 incorporates thrust vectoring.
Here we are at the rear end of an F-A-22 Raptor. First thing you'll notice are the nozzles for the F-119 engines. In flight, during a maneuvering dogfight, they actually move up and down and vector the thrust of the engine to provide maneuverability.
It helps us turn inside any foe, maneuver at low or high speeds to outmaneuver another airplane or potentially an enemy weapon that's headed towards us.
The F-22's stealth, supercruise, and vector thrusting are impressive breakthroughs, but its most outstanding feature may be its ability to nearly fly itself through advanced computerized controls.
It relieves the pilot of all the duties, gives the pilot total freedom to just look out engaged in the combat scenario.
In addition to monitoring its own performance, the F-22 constantly gathers data on other aircraft in the combat area and presents the most important information to the pilot.
We're going to have information passed to us from either unmanned vehicles or from off-board sensors so that we can integrate data and use that information for targeting. And it's the way that we are driving our forces in warfare. We are much more integrated with both other services and with other platforms, and the F-22 fits right into that concept.
The F-22 Raptor's total package of avionics, stealth, supercruise, and thrust vectoring make it the most technologically advanced fighter today.
I've never been in an airplane that accelerates as fast, that's as agile, the ability to turn very sharply, and it just brings a great combination of the speed, the stealth, and the avionics to the fight that nobody else is going to be able to touch.
But there will be future competitors, like the Russian Sukhoi 37, which features thrust vectoring and a radical forward swept-wing design. And the fifth-generation MiG, the 1.22, which some have nicknamed the F-22ski.
The Russians are still very active aircraft developers. They've got a variety of technologies that they're continuing to improve upon and that can be made available to our future enemies. And so that's why we have to stay on top of the technology that we are developing and make sure that it is able to take out anything that other countries develop.
When you look at the adoption by China of the Su-27 and the fact that it'll probably be modernized and improved, that brings up the need for more advanced fighter aircraft in the US. And that's one of the main reasons, I think, why the Air Force is so insistent on the need to have the F-22.
In addition to Russia, other U.S. allies are producing advanced interceptors for export that are superior to the F-15, such as Sweden's JAS-39 Gripen and France's new Rafale. Germany, Italy, and the UK have joined forces to create a Eurofighter, the Typhoon. If these planes fall into unfriendly hands, the U.S. Air Force will need the F-22 to maintain their advantage.
We're always going to go into war wanting to have that air dominance, and the F-22 is going to be the big boy on the block that can help us to do that.
In future combat, the F-22 is to be joined by another stealthy aircraft, the F-35 Joint Strike Fighter, the ground attack bomber of the future. Designed for the U.S. Air Force, Navy, Marines, and Britain's Royal Navy, the question is, will it work for every user? The rules of war have changed. Brute force has given way to high tech, and conventional weapons of the past will no longer be effective. In future battles, the F-22 will be the first fighter to cross enemy lines, surgically removing air and ground targets. Next in, the F-35 Joint Strike Fighter, the attack bomber of the future. It will assume the air-to-ground attack role for the U.S. military. The F-35 can carry heavy weapons externally for maximum effect. But when a smaller payload is carried internally, it is nearly as stealthy as the vaunted F-117 Nighthawk.
It has a significant amount of stealth capability to allow it to be used early on in a campaign, and it has a significant amount of weapons carrying and payload capability to be used at the later stages of campaign. The threat to the airplanes may not be as significant and require that stealth.
The development of the F-35 was driven by the Armed Forces' desire to save costs by creating a ground attack bomber that would meet the needs of the Air Force, Navy, Marines, and Britain's Royal Navy.
Airplanes are becoming very expensive these days, and we had to do something to get the cost of these airplanes back down to a reasonable level.
The F-35 is expected to cost about $40 million, one-third the cost of an F-22 Raptor. But could one basic airframe be designed to satisfy so many different military demands? Each armed service wanted a stealthy ground attack bomber, but the Marines also needed a plane with short takeoff and vertical landing capability. The U.S. Navy required a craft with larger wings, heavy-duty landing gear, and an arresting hook for carrier landings. And the wings would have to fold up to save deck space.
The size and scope of the JSF program is pretty significant. The airplane is being designed to replace the F-16 and the A-10 for the Air Force, the AV-8B for the Marine Corps, and the FA-18 for the Navy.
Unlike the twin-engine F-22 Raptor, the F-35 Joint Strike Fighter was designed around a single engine to keep down not only costs, but weight. A lighter plane can carry more weapons.
For the Joint Strike Fighter, one of the keys of its mission is the ability to handle a large amount of ordnance and bring it to an enemy site. That all works better with a single engine.
The Air Force version of the Joint Strike Fighter, the F-35A, made its first flight attempt on October 24, 2000. Tom Morgenfeld, who had been a test pilot for the F-22 Raptor, was at the controls.
Well, a million things are going through your mind. Your eyes are everywhere, you're listening, you're watching. Your senses are tuned to an incredible level because you're sensing and feeling the airplane for the very first time. It flies wonderfully. It's definitely a pilot's airplane.
The Air Force testing went smoothly. Next, a Navy version was built with heavy-duty landing gear and wider wings for the slow speeds needed to land on carriers. Navy test pilots flew touch and goes, demonstrating the F-35's ability to land within the space of a carrier's flight deck. But the most difficult challenge still lay ahead for the F-35 program. The Marine Corps needed a version that could perform short takeoffs and vertical landings, STOVL for short.
The STOVL capability is extremely important to the Marine Corps because the airplane can go just about anywhere that the rest of the forces can go. It's not limited to needing a large runway. It doesn't need a really big ship to operate off of.
Engineers at Lockheed Martin, the designers of the F-35 Joint Strike Fighter, took a hard look at the AV-8B Harrier, the STOVL fighter that the new aircraft would have to improve upon.
The Harrier is a great airplane if you look at the fact that it's basically 1960s technology. It's achieving all those wondrous STOVL flight sort of maneuvers without the aid of a lot of computers.
The Harrier's ability to take off, hover, and land vertically is achieved by vectored thrust. The powerful force of its jet engine is directed downwards through 4 nozzles that can pivot 90 degrees.
I was brought in because I am a Harrier pilot with almost 1,600 hours in that airplane. So all of the lessons learned I have from the Harrier airframe and operational experience I have, I was able to bring to the program and use those to help evaluate the X-35 STOVL version.
For hovering, engineers gambled on a radical new system. They planned to supplement the vectored thrust method by harnessing the jet engine to a drive shaft that would power a fan to blast air downward.
In 1991, we unveiled this shaft-driven lift fan system to the technical world. Some actually said, "You gotta be kidding me. Are you guys serious?"
The lift fan required doors to open behind the pilot on the top and bottom of the plane to draw in more air. The fan would blast air down mid-ship, while the jet nozzle in back swiveled, blowing its powerful exhaust down to create a balanced lift force.
The shaft-driven lift fan system allows you to harness a lot more energy out of what the engine is producing.
But harnessing a jet engine to a drive shaft proved to be extremely difficult.
The mechanical energy we were dealing with in the shaft-driven lift fan system was very large. We had 28,000 horsepower being transmitted from the drive shaft from the main engine to the lift fan. And that's similar to the power going through a U.S. naval destroyer.
The lift fan's ability to blend large amounts of cool air with the hot jet exhaust provided another important benefit.
One of the things we learned in JSF was to combine the jet exhaust to get a lower combined temperature than the Harrier. This allowed us to avoid some of the problems with concrete where the concrete would actually burst and explode under the high temperature and high jet exhaust from the Harrier.
At the Lockheed Martin test facility in Palmdale, California, the revolutionary lift fan system was put to the ultimate test, in the air. If the lift fan failed during hover, the plane would crash.
It made its first flight in 2001, and it was a complete success. And at that time, I didn't hear any more from the people who had been saying for years, this thing will never work. It worked.
Now, all three versions of the F-35 for the Air Force, Navy, and Marines are being developed and further tested for mass production. The United States, Britain, and their allies are expected to order more than 4,000 Joint Strike Fighters, which will replace most American-built fighter bombers in use today.
The handling qualities and performance are stunning. It really is a pilot's airplane. It sort of makes you feel like a little boy. You want to take it home and tuck it under the pillow with you at night. It's just a pilot's airplane.
In future air conflicts, the F-22s will be used to establish air dominance. Then waves of stealthy F-35 Joint Strike Fighters will use their superior weapons-carrying abilities to attack other major ground targets.
The Joint Strike Fighter is going to be the backbone airplane for hauling freight. It is going to be the muscle part of sustained forces.
Commanders can also alter an F-35's mission in the air as situations change during the battle.
There are a variety of ways for the F-35 to bring in information from external platforms, other airplanes flying around the battlefield, satellite-based assets, ground-based assets. All that information can be presented to the pilot in the cockpit and allow him to be more of a tactician and manage the tactics of the game that day instead of worrying about the nuances of flying the airplane.
The pilot's job will be to supervise the process of identifying the target and then to give consent for weapons release.
The Joint Strike Fighter will be able to carry a wide range of weapons, to include the heavier weapons such as the 2,000-pound bunker busters and 2,000-pound blast weapons.
The Joint Strike Fighter's 1-ton bunker busters and blast bombs will be guided to their targets with pinpoint precision by JDAM tail kits. The Joint Direct Attack Munition, or JDAM, is a kit that can be put on any bomb to give it the brains to know where to go, and the movable tail fins to guide it there.
JDAM is a guidance kit that came after Desert Storm. This little round piece on the side there is an inertial navigation clock. Now this clock, instead of measuring seconds, measures feet. If you take the unit and you tell it where it is right now electronically, and then you move it back a foot, or you move it up a foot, it measures every centimeter and every distance.
The bomb knows the coordinates of where the airplane is, and it also knows the coordinates of where the target is. And when the weapon is released from the airplane, it simply flies from one set of coordinates to the other and does its thing when it gets there.
Because a JDAM is directed by GPS, or global positioning satellites, it can hit targets regardless of visibility.
The way we use it is by employing it against targets that we cannot normally see visually, whether it is due to weather, smoke, haze, or just some sort of other thing that's obscuring the target.
As a JDAM falls, its inertial clock keeps track of its position and signals the tail to make course corrections, directing it to the target. The accuracy of new weapons like JDAMs will reduce collateral damage. It also makes the F-35 an even more formidable weapons system.
The new weapons such as JDAM really reduce the need for the number of sorties, and that reduces our risk because we're not exposed to enemy threats as often.
The F-35's combination of advanced weapons, avionics, and stealth will help it ensure its success over the battlefields of the future. U.S. military planners wondered if these same features could be utilized in a helicopter. They wanted a stealth helicopter. But could it be done? Over the last 50 years, helicopters have evolved from slow-moving multi-purpose support vehicles to fast-moving frontline attack ships. But in the high-tech wars of the future, speed alone is not enough. Information is the key.
There's three elements that are critical to warfare. The ability for you to know more than the enemy, the ability to maneuver quickly around an enemy and gather more information about them, and the ability to provide precision firepower at the enemy.
In future conflicts, after the F-22 Raptors and the F-35 Joint Strike Fighters have cleared the way, surveillance and attack helicopters will support ground troops as they move in to secure the area.
We like to be down low where the action is, and we like to be down low where the threat can't see us.
But at such low altitudes, helicopters are vulnerable to a wide assortment of ground-to-air weapons.
All the simple systems, the guns, unguided rockets, the surface-to-air missiles, it's got to deal with all of that, and it's got to deal all of it effectively.
The Pentagon has responded with a two-pronged strategy to counter this threat: inexpensive, expendable unmanned helicopters and stealthy manned helicopters. Unmanned helicopters will be primarily used for surveillance and for gathering targeting information. Fire Scout, designed by Northrop Grumman, was specifically developed to take off and land on Navy ships. However, the key to creating a successful manned helicopter for future combat is to make it stealthy like the F-22. But the question is, can it be done?
Achieving stealth in a helicopter is different from stealth in a fixed-wing aircraft. You're concerned about different signatures: radar reflectivity, infrared, noise, all things that will give away an aircraft's position.
Those signatures, like heat, smoke, and sound, put helicopters and their pilots at serious risk over the battlefield.
All the small shoulder-fired missiles, which are very effective against helicopters, are heat-seeking infrared systems.
The challenge for engineers was to create a quiet helicopter with very few signatures and a small radar cross-section. And that's exactly what Sikorsky has done with the new RAH-66 Comanche.
In the Comanche, with all the stealth capabilities, we can defeat the radar threat. We can defeat the guy with the shoulder-launched heat-seeking missile. And from the guy popping up in the tree, our agility defeats him. Our small size, our quiet acoustic signature defeats him.
Often the first thing you hear from a helicopter is the sound of the wake from the main rotor hitting the wake from the tail rotor.
In the Comanche, the fan tail is shrouded, so there is no interaction between the fan blade tips and the main rotor tips, and it's also canted slightly. And those all contribute to reducing the acoustic signature.
Engineers also experimented with the main rotor to find a quieter design.
If you look at a Comanche, it's got a 5-blade rotor, and what that does is it cuts down the normal chop, chop, chop sound from a helicopter into a more discreet whir that kind of blends into the background.
Reducing the heat signature of a helicopter is also essential to making it more survivable.
When you look at a Comanche, the first thing you ask yourself is, where's the exhaust? Where does all this hot air get out of the engine?
The Comanche's exhaust actually escapes through the tail boom, where it is instantly dispersed by cool air from the rotor.
That missile has to have something to home in on, and that's a heat signature. Comanche defeats that by the engine exhaust being mixed with ambient air and cooling it so that there's no longer a heat plume for that missile to home in on.
To defeat radar, the Comanche utilized the stealth secrets first developed for the F-117 Nighthawk. There are no radar-reflecting right angles on its outer fuselage, and all weapons are carried internally to help keep its stealthy shape.
What's interesting about the helicopter is some of the things that achieve stealth actually make the helicopter better. Things like the retractable landing gear and the retractable weapons bays, that also makes it sleeker and faster. So once you've bought into the stealth part of it, you get other superior attributes.
The main role of the Comanche is to give commanders an overview of the battlefield by providing up-to-the-minute information.
Comanche is going to be basically their flying cavalryman. It's going to dart in and out, slash and cut, be a reconnaissance vehicle.
As Comanche's two pilots gather data, their computer shares that data with other Allied forces.
When the Comanche finds the enemy, he's going to kind of direct like a quarterback to apply the firepower to defeat that enemy.
Engineering advances have also made the Comanche one of the easiest and most forgiving helicopters to fly.
One thing that Comanche brings that other previous generation helicopters can't bring to the table is the pilot can maneuver the Comanche in virtually any axis without fear of exceeding any limits.
Although it will be used primarily for reconnaissance, the Comanche will also be armed for self-defense.
The Comanche is capable of carrying a wide array of weapons, all the way from guided missiles using a laser guidance system, heat-seeking missiles, which would be more of an air-to-air weapon, or unguided rockets, and also the latest Hellfire is pretty much a fire and forget.
In addition, Comanche's pilots can ask Allied aircraft to fire missiles their way, and can then take over and guide those missiles to their targets. If the Comanche is hit, its computer system can often fix itself by reassigning vital functions to undamaged computer cards.
This is where the computer brain of the Comanche is.
In support of its reconnaissance mission, Comanche can control as many as 5 unmanned aircraft.
When the Comanche may be employed, it may have little vehicles that it launches out, so it has its own little eyes over the hill so it can see what's going on without putting itself at risk.
In addition to launching its own unmanned air vehicles, Comanches may be aided on the battlefield by swarms of LOCAS, small intelligent missiles with their own computer brains.
It's about 31 inches long, weighs a little over 100 pounds, carries a single warhead, has a laser radar. In other words, it has a scanning laser beam that generates pictures.
The LOCAS also communicate with each other and cooperate in searches and attacks.
You could have a swarm of LOCASes, each of which has its own eyes, each of which is thinking, but each of which is communicating with each other. Send that imagery back to the operators who could either use these as surveillance probes or, in fact, as weapons themselves.
Weapons like LOCAS reflect the trend toward electronically linking all Allied forces and weapons so that information can be shared and used by all. By networking aircraft over the battlefield, with surveillance platforms and other weapons systems, commanders can quickly change missions to take advantage of up-to-the-minute information.
The key to the air battle of the future is not necessarily stealth, speed, or firepower. It's going to be information.
Unmanned air vehicles, or UAVs, will provide a large part of that information while flying long-duration surveillance missions. So, will the Air Force of the future have no pilots? Since the very first use of airplanes in war, military planners have looked for ways to make aircraft more effective and more lethal. Once so secret their very existence was denied by the government, unmanned air combat vehicles, or UCAVs, are now poised to take the preeminent role in 21st century air combat.
UAVs are certainly going to change air power in the 21st century. You can see it starting to happen today, but what we're looking at now is just the beginning, because there's going to be more of them, and they're going to be better.
Unmanned aerial vehicles allow the military to do more with less, to put more aircraft into the air than you otherwise would be able to because of the limited number of pilots that you might have, or where it might be too risky.
In the future, aircraft that have no pilots on board will carry out the most dangerous combat missions. Today, unmanned air vehicles, or UAVs, are already taking over the role of long-duration surveillance.
UAVs don't have mothers. You lose a UAV in combat and nobody bats an eyelid.
One of the earliest surveillance UAVs was the Predator. It was developed in the early 1990s.
When you look at Predator, basically they start off as being long-endurance systems that can really persist over the battlefield.
In Afghanistan, Predators provided critical real-time intelligence. And it was there that a Predator made an amazing transformation from surveillance to armed aerial attack.
Fired a Hellfire missile, an Al-Qaeda convoy, and destroyed one of the vehicles in there. And at that point, it crossed the line from an unmanned aerial vehicle into an unmanned combat aerial vehicle.
Today, the new Predator B can carry up to 10 Hellfire missiles. Of course, its primary mission is still what the military refers to as ISR, or Information, Surveillance, and Reconnaissance.
It's basically a poor man's satellite. I mean, you can bring it in and let it dwell in an area.
UAVs transmit important visual information to battlefield commanders via satellite or other data links.
Once targets had been located, identified, and cataloged, these could be disseminated to other weapons or weapon systems.
Reconnaissance UAVs have multiple ways of conducting surveillance. On clear days, they use specially stabilized optical lenses that can zoom to high magnification. At night, they use infrared, and under adverse conditions, they use synthetic aperture radar to pierce the thickest clouds, sandstorms, or oil field smoke. When the radar is reflected back, it can also be used to create a 3D image of objects.
If the enemy chooses to use countermeasures or decoys or deception techniques, having to beat 3 systems is a lot harder than 1.
The success of the Predator paved the way for the development of an even more advanced high-altitude jet-powered UAV by Northrop Grumman. It's called the Global Hawk, but unlike the Predator, it was designed to take off, fly its pre-programmed mission, and land all on its own, thanks to the GPS, or Global Positioning Satellite System.
The Global Hawk is basically a much larger version of the Predator. It has higher altitude capabilities, increased payload. It can carry a lot more sensors, a lot more communication devices, and it can loiter over a battlefield for up to 35 hours.
The Global Hawk can stay aloft for a day or more, providing constant near real-time video surveillance over an area the size of Illinois.
Predator and Global Hawk give us an up-close view, which is something you can't get from a national asset, which would be a satellite type of thing.
Though still in development, the Global Hawk had a dramatic impact during Operation Iraqi Freedom. A single prototype provided information to Allied forces on 55% of all time-sensitive targets, including mobile Scud missile launchers. Like the Air Force, the Navy wanted its own autonomous UAVs. However, designing one to take off and land on an aircraft carrier was a tremendous challenge. But the engineers at Northrop Grumman were up for it. In the summer of 2000, they began working on the X-47 Pegasus.
The hardest part of the Pegasus program was definitely the flight controls. Getting on and off an aircraft carrier, of course, is one of the toughest design problems for an aircraft. And doing this with a tailless vehicle like Pegasus certainly was the toughest problem we had.
That problem was solved by using 6 innovative surfaces to make the plane climb, descend, and turn.
This surface just rotates up.
the elevon, of course, both up and down, and then there's another inlay on the lower surface as well.
The first flight of Pegasus, the demonstration was very, very successful. It lasted approximately 12 minutes. There was no human in the loop.
But could Pegasus, without any human assistance, land within the tiny space between the arresting cables of an aircraft carrier? The engineers came up with an ingenious way to find out.
And we actually glued a small paintball down onto the bottom of the hook so we could get a clear touchdown point. That was quite an achievement that we're very proud of.
The Navy will use its stealthy UAVs to get targeting information for its guns, missiles, and fighter aircraft.
The initial focus has been on information, surveillance, and reconnaissance to provide targeting information to the Navy's strike packages.
But many future UAVs, such as Boeing's X-45 unmanned bomber, will be heavily armed. Although flying pre-programmed missions, armed UAVs will still need human permission to fire.
It has to know where friendly forces are on the ground, where civilians might be, where collateral damage, i.e. hitting a church or a mosque, might be an issue. So there is an element that we always retain where a human in the loop is important.
You can have a weapon that's doing its own surveillance and has its own ability to engage a target. And that gives you a level of dominance that we're just emerging on right now.
In the not-so-distant future, there will be even more radical aircraft and airborne weapons systems. Everything from electromagnetic pulse weapons to powerful airborne lasers to hypersonic aircraft that can fly to anywhere in the world in 2 hours or less. But how soon will these high-tech secrets become a reality? The enigmatic F-117 stealth jet flew in secret for 10 years before its existence was revealed to the public. Some of the unclassified projects that are acknowledged by the Pentagon seem more like science fiction than reality. The military is designing a weapon system designed to neutralize an enemy encampment or factory without destroying it and scattering nuclear, biological, or chemical materials. Electromagnetic pulse, or EMP weapons, will blast a highly concentrated magnetic field towards its target, overloading and destroying any electrical components.
The small electromagnetic pulse weapons offer some pretty startling capabilities. You can essentially completely destroy an enemy's electronic infrastructure in a very precise way. You can fly over a small facility, only a couple of acres, fire it, and suddenly none of their computers work, none of their weapons work, none of their electronics at all will work.
Researchers are also experimenting with an airborne chemical laser.
An entire aircraft has been turned into a chemical energy plant that points that laser at a target and burns through missiles.
This aircraft will fly at higher altitudes and will primarily be used for Scuds or for ballistic targets that would be fired from one country to another.
American generals don't want a fair fight. They want their equipment to be the absolute best in the world so that whatever they come up against, they can defeat it quickly and efficiently.
The battlefield of the future will continue to be a dangerous place. But military planners believe that the key to maintaining the security of the United States is to develop the weapon systems of tomorrow, today.